basic concepts, units and dimensions. In this lesson, the learner will be able to explain the concept of mole, discuss concentration units such as mole fraction, weight fraction, molarity, normality and molality. Know about vapor pressure and partial pressure. In chemistry, everything deals with atoms and molecules which are really small. Even a drop of water will have billions of atoms. Counting the molecules individually would be completely impractical. Now, what do you mean by a solution? Solution is nothing but a homogeneous mixture wherein a solute gets dissolved in a solvent. The solvent used could be gas, liquid or solid in state. Let us see some more examples for a solution. Atmosphere is an example of a gaseous solution and nickel alloy is an example for a solid solution. Before entering into the mole concept, let us see some examples so that we can get an idea about the mole concept. What you think when I say 1 dozen of apples? It is nothing but 12 apples. What you think when I say a pair of shoes? It means 2 shoes. Similarly, 1 mole is equal to 6.02 into 10 to the power of 23 atoms or other elementary units such as molecules. Here the number used, that is 6.02 into 10 to the power of 23, which is called as Avogadro's number, Na, or Avogadro's constant. Now let us see an example of how to count molecules using moles. How many molecules are there in 0.001 moles of water? Actually, we know that 1 mole of any substance is 6.02 into 10 to the power of 23 molecules of that substance. Now we calculated the molecules of water by multiplying 0.001 moles of water with 6.02 into 10 to the power of 23 water molecules, which is divided by 1 mole of water. Now let us see an example of how to count moles using masses. How many grams of water do we get for 1 mole of water? Actually, 1 mole of any substance is the molecular weight of that substance in grams. For example, H2O has a molecular weight of 18.0. Hence, 1 mole of water is equal to 18 grams of water. Let us discuss about concentration units of solution. Actually, there are several methods to quantify the amount of solute dissolved in the solvent, which is collectively called as concentration. They are mole fraction, weight fraction, molarity, normality and molality. Mole fraction is defined as the number of moles of a particular component in the solution divided by the total number of moles of all the substances present in the solution. Therefore, mole percent is equal to 100% into mole fraction. Weight fraction specifies the fraction of weight of a particular component by total weight of a solution. Thus, weight percent is equal to 100% into weight fraction. Let us see an example when we say there is 25 weight percent of tetramethyl ammonium in methanol. It is understood that there is 25 grams of tetramethyl ammonium for every 100 grams of methanol. Molarity is denoted by the letter M and it is equal to the number of moles in the solute per liters of solution. Normality is denoted by the letter N and it is equal to the number of equivalents in the solute per liters of solution. Molality of a solution is defined as the number of moles in the solute per kilogram, that is 1000 gram of solution. Let us see an example. When water is heated in a flask, the water vapor can be seen above the surface of the water level. Thus, a pressure is created by the vapor over the liquid. This is called as vapor pressure. To understand the vapor pressure clearly, let us see the pressure-temperature diagram of water phase. Here the substance that is above the critical temperature but below the critical pressure is said to be gas, whereas the substance below its critical temperature is called as vapor. Vapor pressure is the pressure of the vapor and liquid of a pure component in equilibrium. Let us discuss some of the proposed functional forms to predict the changes of vapor pressure from temperature. One of the proposed functions is the Antoine equation. Natural log of P star is equal to A minus B divided by C plus T, where P star is equal to vapor pressure of the substance in millimeter of mercury. T is equal to temperature in Kelvin. A, B, C is equal to constants for each substance. The Clapeyron equation is another function relating to vapor pressure and temperature. It is denoted as dP star divided by dt is equal to delta H cap V divided by T into Vg cap minus V1 cap, where P star is equal to vapor pressure of the substance in millimeter of mercury. T is equal to temperature in Kelvin. Delta HV is equal to latent heat of vaporization. Vg and V1 is equal to specific molar volumes of vapor and liquid respectively. Clausius-Clapeyron equation is derived from Clapeyron equation. Therefore, the equation is written as natural log of P star is equal to minus delta H cap V divided by R into T plus B. Let us discuss about partial pressure of a component that is present in a multi-component system. Consider a binary mixture having components A and B. As described earlier, liquid converts into vapor by heating. The pressure associated with any one component present in the vapor mixture is called as partial pressure. For example, the pressure associated with individual component A is called as partial pressure of component A and denoted as PA. Similarly, partial pressure of component B is denoted as PB. For multi-component system, the partial pressure of component I in the vapor phase is equal to the function of mole fraction of component I in the liquid phase. This functional relationship is given by Henry's law and Raoult's law. Let us discuss about Henry's law. The Henry's law equation is given as Pi is equal to Xi into Hi, where Pi is equal to partial pressure of component I in the vapor phase. Xi is equal to mole fraction of component I in the liquid phase. Hi is equal to Henry's law constant. Let us discuss about Raoult's law. The Raoult's law equation is given as Pi is equal to Xi into Pt, where Pi is equal to partial pressure of component I in the vapor phase. Xi is equal to mole fraction of component I in the liquid phase. Pt is equal to vapor pressure of component I. If the vapor behaves ideally, then partial pressure Pi is equal to Yi into P. Hence, the Raoult's law becomes Yi into P is equal to Xi into Pt. By rearranging the above equation, we get Yi divided by Xi is equal to Pt divided by P is equal to Ki, where Ki is the vapor-liquid equilibrium constant. 1 mole is equal to 6.0221479 into 10 to the power 23 atoms or molecules. Mole fraction is defined as the number of moles of a particular component in a solution divided by the total number of moles of all the substances present in the solution. Weight fraction specifies the fraction of weight of a particular component by the total weight of a solution. Molarity is equal to the number of moles in the solute per liters of solution. Normality is equal to the number of equivalents in the solute per liters of solution. Molality of a solution is defined as the number of moles in the solute per kilogram, that is 1000 gram of solvent. Vapor pressure is the pressure created by the vapor over the liquid. Partial pressure is the pressure associated with any one component present in the vapor mixture.